Okay, Ariana is asking what was the correct the answer. The answer was 0.53. Right? It was because the correlation is the R is 0.73, and if you look at the coefficient of determination is R squared. So that's basically 0.73 times 0.73. Okay, which is rounded, it is 0.53. Yeah, so that was a mistake on my part with the answering key. That's why I showed that first, that it was wrong. That's why I sent out the correction that the right answer is 0.53. So I apologize for the confusion, but if it was wrong, that was the right answer. So it's really, that's an important one to understand, right? R squared is simply a correlation coefficient squared. And it's actually the same thing for the regression, right? If you happen to have worked on that already. So who that is in the meeting has already started working on the regression module? No one. Okay, well, do you guys want me to talk a little bit about that? Okay, so I'll just give you a brief introduction, and what I'd like you to do is, let me see here. Well, first of all, what is the regression really all about? The regression is very similar to correlation, right? It looks at relationships between variables. But now we're not just saying that something goes together or doesn't go together, right? Or there's a neutral relationship. We actually say now we're trying to predict one variable with the other. So we're trying to say, if you have an A in your statistics class, well, what would I think? What kind of grade would you get in your research methods class, right? So probably it's going to be a positive relationship, right? People that do well in stats probably do pretty well in research methods as well. However, research methods has a little bit more, reading, literature reviews, writing. So it's not going to be a perfect correlation, right? It's not going to be a correlation of one. But they have something to do with each other. And now we could say, okay, how much of the variation in the research methods grade can we predict with the grade from statistics? If it's a perfect relationship of 1, what is the R squared? And while you think about that, I'm going to set up the answering sheet for tonight. That's going to be your first question. If the correlation or the regression coefficient is 1, what would you think is the explained variation, the R squared? And I'm going to, just as you think about this, I'm going to post a link to the spreadsheet for tonight. And if you haven't looked at the at the module yet, some of the things I'm going to say might be a little bit confusing. I don't want to jump ahead of things, but I just want to give you a gentle introduction so that when you work on the module, that it's it's a little bit easier, makes a little bit more sense right away. So, the same thing that we had in the correlation coefficient in R square, we have the same R squared for regressions as well. Right? We're trying to predict one variable with the other. And the one variable that we're trying to predict is the dependent variable. The one that we use to predict is independent. Right? The dependent variable depends on the independent one. Another thing is this, you might be familiar with linear equations, right? So regressions require linear relationships. Linear, like a line, right? Linear meaning a straight line. And that's why at the first stage of a regression analysis, what you should do is to do a scatter plot, right? To see on one axis you have the x variable, on the other axis you have the y variable. Then you get a scatter plot, right, with all the dots. And you're going to see, well, do these dots kind of align in a linear fashion? Or if you see something that's roundish, that's like a U, upside down U, or like a hockey stick or something, it would tell us that the relationship is non-linear, right? So a non-linear relationship would not be suited for a linear regression. We could still do regressions, but not linear regressions. So that's what we're worried about right now. So the first thing you're going to know, is it a linear relationship? And once we determine that it is a linear relationship, then we can start going on. And what I'd like you to do now, in case you haven't yet, is to go into Blackboard and jump into module 10 and look at those graphs where you see the illustrations of the different relationships. Right, and there you would see examples of what I'm talking about. It's much easier to just see it. So I just posted a link for the attendance right now. Can you guys see it? It's in the chat. And please enter your first and last name, and then answer the first question. If the regression coefficient is 1, what is the R squared? Right? If the relationship is perfectly 1 between one variable and the other one, if one goes up 1, the other one goes up 1. So you could almost say the correlation is 1. What is the R squared? Yeah, so you guys are on the right track. All right, so I'm going to show you guys an example right now of how you can adapt the Excel sheet that I put online to solve simple linear regression problems. Okay, I'm going to start sharing. I have a little bit, I apologize, my computer's very slow tonight. So I'm going to start sharing my Excel spreadsheet with you guys. Any questions so far about regression? So right now we're just going to talk about when you have one variable. You can add multiple variable, which is a multiple regression, but we're not going to go into this in this course. But just so you know, you can use multiple variables to predict an outcome. Right? Actually, that's the most common thing, right? We try to use several variables to predict something. For example, you could say, I want to know if, to predict academic achievement, you say, okay, I want to know, is it a boy or girl? What kind of social background do they have? Maybe you can say, what kind of profession do the parents have? Which neighborhood do they live in? And, what kind of preschool did they go to? Right? And all this information would help you predict academic outcomes. Hey, can you guys hear me? Oh, okay. I'm on the other one now. Hey, I got huge problems here. So bear with me. Just let me know. I'm on the other computer as well. Okay, I see not everybody answered the question 1 yet, or at least I can't see it. All right, I'm going to turn the other side off here. Okay. All right. I apologize for this here, but finally got the other thing to stop working. So we're going to work through a problem if that's okay with you guys. So the question is here, and you're going to see this question. I'm going to put this up in the exercise as well. The question is this here. You have a school, you have different universities, Princeton, Harvard, Caltech, etc., Stanford, all the way at the end. And then we have a mid-year salary in thousands, and we have a yearly tuition. Okay. Now, my question is it worth paying Stanford $54,000 for 1 year and then making $114,000 a year afterwards? Right? Let's just say purely economic. Is it worth it? What is your guys' hypothesis? Is it worth it paying a lot of tuition just for the income? Marissa, what do you think? Mario says no. Alex said, don't think so. Mika's all no. Marissa, no. Jorge, yes. All right. So there are some people that think it's worth it. Some people say don't. Okay. All right. Now what I'm going to do here, let's see. Let's make this experiment. I would like you to be able to work with me here. Let's see if I can put this in the chat. Oh, no, that doesn't work out at all. Okay. All right, so I'm going to have to do this differently. So I'm going to post this right now on Blackboard, just the numbers. Okay. So you're going to have to figure out what are these numbers and how can you work with them to answer this question. So the first thing what you would do is to create a scatter plot, right? We would want to know what kind of relationship is it between those numbers? Oh man. All right. So in order to create a scatter plot, we'd highlight a cell down here. And it's pretty straightforward. You highlight the areas that you want. So mid-career salary and yearly tuition. And then we go into charts. And then we hit the scatter here. And we are going to ask for a marked scatter. Okay. So let me ask you this. What do you think? Is this going to be are we going to have a problem here? Is this a linear relationship or not? What do you guys think?
Not a linear relationship.
Chart. So that's going to be question number 2 on our spreadsheet. Is this scatter plot, is this a linear function or not? What would you guys say? Is this linear or not? Not linear. Why would you say not linear if you drew a line through these points? Okay, now I'm going to ask you the question. What if you ignored West Point and US Naval Academy? Would the scatter plot linear if you ignored West Point and the US Naval Academy? So what I did now is I posted the data on the announcement, right? So you should be able to go there and copy it. Can you guys highlight, when you look at the announcement, can you highlight that and just copy paste it? Does that work? On my end, it looks a little bit different. All right, so Alex, I would agree with you. I hope the others agree with Alex as well, right? If you ignore the Naval Academies, it looks kind of a negative curve, right? A negative relationship. The curve goes from the upper left to the bottom right. Okay. So we could say, all right, we can do it. Let's just ignore those two. And now what I would do, right? You could take the spreadsheet from the from the exercise where I explain it. Right? You have that little area in the module 10 where I explain it, and we could just add it in there. Right? We could say, okay, now our y. Which one is the y variable? Right, y is always the one that we're trying to predict. So this is question number 4 on the spreadsheet for tonight. Which one is the y variable? What are we trying to predict? I'm going to wait a little bit for you guys. What are we trying to predict? Are we trying to predict mid-career salary, or are we trying to predict yearly tuition? What's our criterion? The criterion is the thing that we're trying to predict. The predictor is the thing that we use to predict the criterion. What are we trying to predict? Right? The question is, does the higher cost of tuition translate into higher paying jobs? Right? If you pay more, will you get more salary?
Dr. Wandeller?
All right, so the yearly salary is what we're interested in to predict. And we're using as a predictor, we say, okay, how much did these people spend on their yearly tuition in college or university, and what kind of salaries are they making afterwards? So I would take mid-career salary, copy that, and we paste it in this form here under the y variable. Actually, we can, let's just first delete everything. So we paste in the salary, and then we paste in the yearly tuition. Okay. And then you know what? We're just going to eliminate. Well, let's wait. We're not going to eliminate the military schools yet. So now what you can see is this is all set up for you guys, okay? But what we have to change now, we predict, so we have the y, we have the x, okay? And now ignore this for a moment. What we're gonna do is we're gonna try to predict the slope, right? The slope is the regression coefficient, right? So Alex said that we're expecting a negative slope, right? So the formula for the slope is Rxy, that's the correlation, right? Times the standard deviation of y divided by the standard deviation of x. So first we have here the formula that calculates the correlation, right? Correlation B3 to B13, that's here. B3 to B13. Oh, I got to adjust this, right? To make sure you get the right formulas. right? Correlation is B3 to B12 and C3 to C12, right? So we got to adjust it. We did that. Okay, that's good. So we have here a very small correlation. Okay, then we got this correlation here is negative 0.15, right? So from what we observed from the scatter plot, this looks okay, right? It's slightly negative. Looks right. Now the standard deviation, again, formula standard deviation B3 through B13, it's wrong, right? Because we use this pre-formatted file. So we go B3 through B12. That's the standard deviation Y. And C3 through C12 is the standard deviation for X. So we get that, okay. Now here the formula I typed this out to make it explicit for the other examples. So I'm just gonna type this out. You don't really have to do this. This is just an illustration, right? So this formula would be the correlation, negative 0.15 times standard deviation of Y, that's 7.93, right? That's this value right here, times 18, divided by 18,387.24. All right. And this here is the formula, right? So you see the beta is a very small number. It's a very small number. Okay. So now what we're going to do is we're going to predict, the prediction, right? The formula for the regression is this. It's Y hat, or Y with this little arrow, this little sign here. It's a Y hat, but that's hard to do, right? So this Y hat equals A plus B times X, right? So A is the intercept, Bx is the slope, B times the X value. Okay. Now, once we know the beta, the B, we can figure out the intercept, right? The intercept is just the mean of Y minus B times the mean of X. So the mean Y is B3 through B12, right? That's the average salary. So the average salary of our group is 122.50, right? If we go up here, that's the average salary here of this group is 122.50. And now if we want to figure out the average tuition, right? We get the average tuition here. And that is C3 through C12, which is 32,831.40. Okay. Now if we plug this into our formula for the intercept, we get 122.50 minus the beta times 32,831, and that gives us 124. So what does that 124 stand for? I'm gonna just quickly change this around. 122.50 times minus the beta, it's a negative 0 point something, times 32,831.40. So that's our value. So this is our formula. Now we are gonna plug this into our regression formula. We have the A, The A is 124.56. Okay, that's 124.56. Oh, I got a round. 0.569, which is 0.57. Right? If you wanted to, you could go further, but we don't have to be that precise right now. Then it's not plus 0.96, but minus 0.15 times x. Okay. So I'm gonna copy this, right? This is again just to really make it explicit, to explain it well. But we're gonna copy this value into the y hat column, right? This is what we're gonna use to predict our values, right? So it's equals 124.57 minus 0.15 times x. X is this variable, this field here, C3. So in this case, we would predict the yearly the mid salary actually to be negative. I just want to make sure this is correct here. No, this is not correct. Right? I typed, what mistake did I make? You guys got to speak up, right? I punched in the minus 0.15, which is the correlation, but we don't want the correlation, we want the beta. So the beta is this here, is basically a negative 0.00 something, right? It's a very small number, right, in the scientific notation. So what we're ending up with is a formula that I'm going to adjust here. I'm going to come over here. Right, and now we're going to use this. All right, so it tells us, you know what? This is a very bad regression, right? This naval example, these guys are really throwing us off. So what I'm gonna do here, I'm gonna create a copy of it. Okay. And this is gonna be without the military because the zeros are really sabotaging our regression. Right? So here you see a good example of what happens if you do include outliers. Make sure is everybody on board? So let's look at this. Let's take the tuition out here. Let's say what happens if we took the Naval Academy out and West Point we take that out, we clear this up. And now what happens is we're going to have to do the adjustment again. All right. So let's do this adjustment. And move things up. Okay. And now what do you think is going to expect? And this is going to be question 5. What do you think is going to happen to the beta coefficient? When we take out the military universities. All right, so what do you think is going to happen? Let's see here. First of all, we're going to adjust the regression. All right, it's B10 is right, okay. B3 to B10, C3 to C10. Oh, wow. Now we see the regression is strongly negative, right? Negative 0.71. We get the good, okay, the rest is all good. And now let's change the formula for our beta, right? Let's say here, instead of negative 0.15, we say negative 7.1 times 8.94 divided by 7.051. Okay, and now we're gonna plug that into our predicted formula, right? We say, what's it starting out with? What's the A? Let me see here. So, right, we have the right averages, right? So now here we plug this in, so that number should be correct. Just gonna adjust it here. It will be 122.88 minus 0.0 is still accurate, times 41,039.25. Okay. And now for the y hat, the predicted value is the A, 160, right? Times minus 0.00. I'm just gonna really copy this out here. 0.009047, let's say 72, right? Times x. Right, we're gonna copy this and plug it into our formula. It's 160 minus this one. X is our yearly tuition. Right. So now this is a little bit confusing here, the way it's formatted. Let's reduce this, right? We use the zeros to go down. Right? And now we get a negative value. That doesn't make a whole lot of sense, right? It would imply that we have negative salaries. All right. So, for example, we could say yeah, this is not right. How do I know this is not right? Well, no, it could be, but there's something. These values, the y hat, the predicted value should be positive, right? So here we got to go through a little bit of troubleshooting, see what is wrong with our formula. And we're just going to go back to the basics, and we're going to figure out, all right, the first step is to figure out the correlation, negative 0.71. I think that's all right. The second part is to figure out what is the standard deviation, right? I think that one is correct as well. Third part is to figure out what's the standard deviation of our x variable. I believe that one is all right as well. Okay. Then we will go on and figure out, well, did we calculate our intercept correctly? So the intercept would be the mean of y, which is 122.88, times beta times the mean of x. So this formula looks all right as well. So we got to make sure that we have our beta correctly. The beta is our correlation times standard deviation y divided by standard deviation x. Looks okay as well. Okay. And now we're looking at this one here. Sorry, up here. 160, our A, minus 0.09. Oh, you guys see this here? It's 0.009, not 0.009. So let me see here. I'll change this. And we're going to go into our formula here, see if that's going to make a difference. I don't think it. Oh, here it is. That made a difference. Okay. So what you can see here, I tried to model as well what we can do when something doesn't work out, right? So you can see, even as you might imagine, I've done this a number of times. And if something doesn't work out, usually it's something minor, right? So the idea is just go through it step by step and figure out where might have something happened, right? So now it makes more sense, okay? You can see 134,000 is what we predict, and this person actually made 137,000, right? So they made a little bit more than we predicted. The next person made 100. We predicted 123,000. They actually made 135. So they made a little bit more. Okay. And now let me see here. Okay. So what we do then after that is we figure out how well did our prediction work. Okay. So we do the same thing that we did to calculate a standard deviation. Right? We first calculate what's the difference between the observed data and the predicted, right? So this is observed minus predicted. That's that formula here. Observed blue minus predicted green. And here we see we were $2,000, $2,000 above the average. Then here, well, it's, I should say, yeah, 2,800. Here we are 11,000 above, 3,000 above. Oh, then we are 3,000 below. Okay. So because we're sometimes below, sometimes we're above, we're going to square these values. Okay. So the squared errors, and then we're going to add them all up. So that's what you get here in the sums of squared errors. Okay. And then we calculate the standard deviation of the sum of squared errors, which is this formula right here, which gives us the 6.26. So now what I'd like you to show here is also a bit of an easier trick, right? Because regression is quite common and the Excel has a nice little function for it. So we highlight, you know how we did the scatter plot, y and x, we do the same thing for these here. And then we look at the charts, scatter, we choose to mark it as scatter plot. But now what we do here is we're gonna pick a layout for, no, with the function. And here is what it actually gives us. All right, now it gives us this function, and you can see this is not quite the same as what we did, right? So let's see if we choose another we're gonna choose the other option. We're gonna put the income on the y-axis, and we're gonna put the tuition on the x-axis. And Alex was suggesting that earlier, right? That was actually a good idea, right? We want the x values, we want those to be on the x-axis, and the y values, we want to put those on the y-axis. So we switch this around, and we're going to say OK. And now what Excel does, it actually gives you the regression formula, right? So you could see it changed it up. It doesn't say A plus B times X. It says A times X plus B, right? So let that not confuse you. And now we see that R squared is 0.509. Right? So this leads me to my final question for you guys for tonight. What happens? How much of the salary can we explain of the variation? How much of the variation of the salary can we explain by the tuition cost? What do you guys think? How much of the variation of the salary can we explain with tuition cost? If you look at this chart here, and particularly if you look at this table here, What would you guys say? Well, if I paid, let's just go by the numbers here. Let's say I paid $28,000 in tuition costs, and then I got $137,000 in salary. Okay, that was the one with the lowest tuition. Let's go to one with the highest. $54,000 was the highest, and they made $114,000. Right, so they paid almost twice as much for the tuition, but they made about $23,000 less a year. So there's a negative relationship. Okay. So as you pay more tuition, you actually were making less yearly income overall. Okay. Because there's a negative relationship. Now, how do we know that? First of all, you guys seen that already in the scatter plot, right? You said there's a negative relationship, but then also we have seen there's a negative correlation coefficient, right? And the correlation coefficient is scale free. It doesn't matter that one variable is in tens of thousands and the other one is in 100,000s, but actually we didn't even do 100,000, right? We just said 20, 40, and so forth, right? So it's in a metric of 1,000, 20,000. So the metrics are kind of confusing because then if you look at the beta, the slope depends on the metric, right? So what this slope here is telling us, that's an unstandardized slope. It tells us if you pay $1 more in tuition, you actually make $0.009 less in income. All right. So as you pay more, you pay more income. So let's just say you pay $10,000 more, right? You can say 10,000 times these 0.99. Right, so I'm just gonna create a new table, a new little field here. Okay, if you pay $10,000 more, you should get minus 0.009 times 10,000 more in salary. Wow. Can't do these little ones here. So you should get in the metric of the metric that you have in salary here, you should get -9. So minus 9,000. Okay, so you see how that works? All right, so the regression coefficient is standardized. That doesn't really matter on what scales you have, right? The tuition is the beta is unstandardized. It depends on the metrics. So remember what I said earlier, right? You guys said, hey, if the correlation would be 1, we could be the regression determination coefficient would be 1 squared. Right? Everybody agree on that? So now we see that the correlation coefficient is negative 0.71. So what is the R squared now? If R is negative 0.71, what is R squared? So it's a negative 0.71 times negative 0.71, right? Which is about 0.50, right? So this r squared of 0.50, right? 1 would be 100%. 0.50 would be half of 1, right? If 100%, 1 is 100%, half of 1 is 50%. So this would be 50.9% of the variation is explained by the tuition cost, which is quite high, right? About half of the salary can be predicted by a tuition cost. And what's probably good news is that actually with increasing tuition cost, your salary does not necessarily go up. Okay, that's what we learned from this simple linear regression here. All right, great job, guys. So this is basically the simple regression here. Questions, comments? So the good question posed as the final will be on Friday, let me make sure I get the right date. Friday the 11th, it will start. And it will be due on Tuesday, the 15th at midnight. And the final will be a repetition of what we had so far. And the goal of the final will be for you guys to kind of repeat everything, understand, hey, what did you actually learn? It also should help you kind of revisit things, learn things again, make sure that you're solid with it. And if you so far have come along and kind of have a good feeling about it, it shouldn't be too difficult. So I won't do a comprehensive review, but what will be on the schedule, what will be on the exam will basically be what was on the first and second exam and the type of questions that were on the quizzes in module 9 and 10, module 8, 9, and 10. The overall class is out of 550 points. But I gotta see, because there was some extra credits. Those will not go into the overall count, but you might, in Blackboard, it's kind of hard to discriminate. So you might see that your score might look lower than it actually is. There will be there will be as much time as you need. I don't know if Maribel is asking if you have access to prior exams. Do you have access right now? Yeah, I don't. I don't think you'll. I'll open up access again to the final exams. The type of question will be similar than the quizzes in the modules, and I believe you have access to the modules, right? Yeah. So. if you have not received grades for certain assignments that you think you turned in, let me know. Wait up. Let me know let me know if you look tomorrow. Let's say tomorrow at lunchtime, if there's things that you turned in that weren't graded, let me know. It should be pretty current. Let me go look real quick. There might be a few things that weren't graded yet. Oh yeah, never mind. No, yeah. So there's a few things that aren't graded yet. Give me some time, and if it's not graded by let's say tomorrow evening, then let me know. If you missed a module but you're working on it, I'll just take off the 10%. You can still turn in late work. That's fine with me, as long I think I want you to learn as much as you can. So please do turn things in as long as you want. All right, I will try to, if you guys want, I will schedule another meeting next week so that you guys can ask some more questions, things that might show up, okay? All right. Well, thank you guys for coming tonight. I hope you have a great Friday tomorrow and a great weekend. And I look forward to hearing from you. If you have questions, if there's things that you want to follow up on, don't hesitate to get in touch. And I will send a message out about if you want to work on pairs, and then I'll post a little survey. People that are interested in working pairs can fill that out, okay? And that way I know who it is. I'll pair you guys up. I'll pair you guys up before the weekend, before the exam. Okay. All right. So I'll post that and explain again. If you haven't caught everything, I'll explain that, and that way everybody else that wasn't in the meeting understands it well. All right. Well, thank you guys. You have a good evening, and we'll talk to you soon. Bye-bye.